Okay, number 5. Which graph shows an object with a constant velocity, and how do you know? All right, constant velocity. Now, remember, here we are, the last two problems, we were looking only at xt, position time graphs. Now we're looking only at vt graphs. All right, vt graphs is what we're looking at here. All right, they're both vt graphs. Now, what is the slope here? What does the slope here mean? It means acceleration. Both of them. All right, both graphs mean the same thing. Slope equals acceleration. All right, so the question becomes this. What kind of slope is this? That's a positive slope. It has a value, right? It's a positive slope. So that means we have what? We have a positive acceleration. What kind of slope is this? Horizontal. What kind of slope is that? Zero slope. That means we have what? Zero acceleration. Zero. If we don't have any acceleration, that means our velocity is traveling at a, oops, that was supposed to be the laser pointer. My apologies. This one, the velocity is staying at whatever this value is. Not going up, not going down, not getting faster or slower. Staying the same. That's constant velocity. No slope on here means zero acceleration. Constant velocity. Here, we have a slope. That means acceleration. Got it? All right, next. Which graph shows an object traveling in the negative direction, and how do you know? Now again, VT, VT. They're both VT graphs. So how can you tell what direction these are traveling? That's a good question. Well, let's just see. This one starts with what kind of velocity? Big. Like that's zero. This is fast and positive because it's above. Remember, if this is zero, those are positive, those are negative. So this starts with a positive acceleration. Velocity. A positive velocity here, and the line is going this way. The line is getting closer and closer to what? Zero velocity. So this graph is showing positive, fast velocity that's getting smaller and smaller and smaller and smaller and smaller, closer to zero velocity. Now, what's the question again? Which graph shows an object traveling in the negative direction? Negative direction. Is this negative direction? Well, some of you probably said it was because there's a negative slope. That negative slope just means it is a negative acceleration because the slope here means acceleration. Well, then how can you tell what direction it's going? This line is above the t-axis. All of these velocities are positive. All the velocities up here above the t are positive. That means this object is traveling with a positive velocity the whole time. This one starts with a negative velocity. Now remember, zero velocity is here, positives are up here, negatives are down here. So this object starts with a negative velocity that's pretty fast. And then the negative velocity is getting closer and closer and closer and closer to what? Zero velocity. So this object is also slowing down because the line is getting closer to zero. Started with velocity, has none at the end. Started with velocity, has none at the end. Both of these are showing slowing down, but that's not the question. It says which one's in the negative direction. What kinds of velocities are these? All of these are negative velocities. The line is below the t-axis. Below the t-axis, negative direction. Above the t-axis, positive direction. Now, v-t graphs, okay? This is where it gets very confusing, because the same question, if you have position time graphs, you're not going to answer it the same way. You're not going to look for the same thing. But for a VT graph, how do you know what direction? Where the line is. Not what the line is doing, but where the line is. It wouldn't matter if the line was like this or if the line was like this. B would be the answer for this question, regardless of whether the line went up or whether the line went down. As long as it's down here, that's negative. Negative. This one, I don't care if the line goes down or if the line goes up. In either case, where is the line? On the positive side of 0. I hope that makes sense. So again, how do you know? Negative direction has to be B, because the line is below the t-axis where the velocities are all negative. All right, last slide. Okay, number 7. Which graph shows the object getting faster, and how do you know? Okay, so now these two questions, 7 and 8, are the same questions that we had, I think, on numbers 3 and 4, but instead of position time graphs, now we have velocity time graphs. Getting faster. That means velocities that are getting bigger. All right? Now, how's this one look? This one starts with, well, hold on, let me write this out. Remember, we have 0 velocity here, we have positives up here, we have negatives here. We have 0 here, we have positives up here, we have negative here. 0 here, positives here, negative here, 0 here, positives here, negatives here. Okay, now, this one starts with 0 velocity, and the velocity is what? Getting more negative, right? Now, question, does that mean getting faster or not? If you're starting with none, can you get slower than having no velocity? So if your velocity is 0, can you get any slower? I hope you're thinking the answer to that question is no. You cannot get slower. If 0 is what you have for velocity, you can't get slower than not moving. So this line, that's showing the velocity getting bigger. Now it happens to be getting bigger in the negative direction. These are negative velocities. So it's getting faster, but going away from the t-axis. In the bottom side, negative part, means it's getting faster in the negative direction. This one, the line is tipped the same exact way. It's just now above the t-axis. This means velocity that's big and positive. And it's getting what? Closer to the 0, which means the velocity is getting less. If the velocity gets closer to 0, that means it's getting less. If the velocity line goes away from the 0, that means it's getting bigger or getting faster. So which one's getting faster? Has to be A, because the line is going away from 0 velocity on the negative side, getting faster. This one's going toward the 0, getting slower. Finally, last one, never thought we'd get here. Which graph shows an object slowing down, and how do you know? Well, notice these lines are like the opposite of what we just had. So that's what I was trying to give you all four options. Like in this slide, these are the only 4 options you have. You can either have a line going up like this one is, or down like this one. You can have a line going up like this, like that one, or down like this one. So these are like the opposites of each other, you see. This one and this one, and this one and this one. So anyway, where was I? I don't even know where I was. Okay, I was asking about this one. So slowing down, we want slowing down. That means velocities that are getting smaller. If the object's slowing down, then the line should be getting closer to what? I want you to think about this. Now that we've looked at this one, if the object is going to be slowing down, the line has to be getting closer to 0. Has to be getting closer to 0. Then if the line's not getting closer to 0, then you're not stopping. Because, see, 0 velocity is what happens when you stop. So if the line is not getting closer to 0, then you're not stopping, and therefore you're not slowing down. So which one of these graphs has a line that's getting closer to 0? Well, this one. It's starting with a very fast negative velocity, and it's slowing down. It's getting closer to 0, but the line's going up. Well, here's the thing, okay? Here's what can be confusing about this. The negative here, all it's telling us is the direction of its motion. It's not telling us how fast or slow. The negative part only means direction. So, in both cases, in A of number 8 and B of number 7, both cases, that's slowing down. That's going from very fast positive to stopping. This is going from very fast negative to stopping. Okay? That's slowing down. This one starts with none. You start with no velocity, and what happens to it? It gets bigger and bigger. It's going up the axis on the positive side, which means that's getting faster in the positive. This one was getting faster in the negative, going away from the 0. Faster negative, faster positive. Getting slower negative, getting slower positive. Those are the only 4 options we have. So I hope that's making some sense. So again, how do you answer this? Well, A is the one that's showing slowing down. How do you know? Because the line starts with a large negative velocity and ends with none. Starts fast, negative, and ends with 0 velocity. That's called stopping. That's slowing down to a stop. So, if it ends on the 0, it just stopped. If it ends on the 0, it just stopped. If it's going away from the 0, getting faster. Going away from the 0, getting faster. I hope that makes sense. I hope maybe this helped. I will be posting a review soon, and then hopefully we can get any confusion you might have cleared up. But there will be questions on the test like this, where I ask you questions about graphs that you'll have to compare, and the comparing of those graphs you'll have to do and then explain, just like you did on this. Okay, very similar types of questions. So again, I would make sure that you can interpret both velocity time graphs and position time graphs for the upcoming test. All right. So I guess that's it for this video. If you're still watching at this point, then you must either like the sound of my voice, you are bored out of your mind, you have nothing better to do, I guess, which is kind of being bored out of your mind, or you're not wanting to miss anything. So you're really not missing anything, honestly. I wish we were going to be going back and being able to get together at some point in the month of May at school, but apparently that's not going to be in the cards. So I will try to schedule a Zoom that we can all kind of jump in and at least see each other's faces a bit. Anyway, take care of yourselves. Be safe. Have a great, what is today? Tuesday. Have a great Tuesday, and we'll hopefully talk at you soon. Bye.